Good day, learners! Today we are going to discuss degree and radian measure in trigonometry. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be updated for my upcoming videos. In this video lesson, we are going to discuss degree and radian measure. Measuring angle. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. There are two common ways to measure angles, in degrees and in radians. This is now in degrees. And the second illustration, it shows in radian form. Here are the some measuring tool. The first one is we have protractor. Protractor is the most commonly used measuring instrument for measuring angles. The next one is we have pivot square. This is an aluminum pivot square, has a locking adjustable leg that firmly holds any angle from 0 to 90 degrees. So you can make repeated consistent mark or guide your circular saw through marks, or guide your saw through angled crosscuts. Spirit vials help you check for level as when establishing the angle to cut siding where it meets of roof line. Next we have three-sided squares. This three-sided squares is a carpenter's classic. Use it to find angles, marks cut lines, and as crosscuts to guide your saw straight. Stick with the aluminum alloy version, not the plastic. It is more rugged and the stamp numbers are easier to read. Next is we have square shooter. This layout weapon for wide pieces of lumber has a sliding knob along its semicircular arc. Lock the triangle at the desired degree, then press it, and a fixed knob on the handle against the edge of the work. The 12-inch blade can't wobble or pivot as it guides your pencil or your saw. Next is we have now the T-bevel. T-bevels, which have no markings, are great for matching and transferring angles, but can't tell you exactly what those angles are. Find out, align the bar on this guide with the T-bevel's blade and read the angle to the half a degree. Or set a desired angle and align the bevel's blade with it. Next is we have now the bevel protractor. It is a classic mechanics tool for anyone who values precise layout marks. The rotating 180-degree head locks the rule at a desired angle or tells you the exact angle of an existing bevel. Next is we have the digital protractor. This angle finder is arguably the most accurate tool to test, and certainly the most idiot-proof. Press each of its leg in a corner and get the digital readout to a tenth of a degree. The tool comes out with two vials, so you can make sure it is level on both sides of the corner as you take the reading. Degree measure. Degree measure. What is a degree measure? A degree, usually denoted by this symbol, the degree symbol, is a measurement of a plane in which one full rotation is positive 360 if the rotation is counterclockwise, but negative 360 if the rotation is clockwise. And take note that half circle is 180 degrees, called straight angle. Quarter of a circle is 90 degrees, called right angles. Example number 1. Find the angle in degree measure of 2/3 rotation counterclockwise and sketch the graph. So first thing we need to do is we are going to get now the 2/3 rotation, and take note when we talk about one full rotation counterclockwise, that is positive 360 degrees. So all we need to do is we have to multiply now the fraction 2/3 by positive 360 degrees. So we have 2 times 360 degrees divided by 3. So that becomes 720 degrees divided by 3. So as we are going to divide now 720 degrees divided by 3, the angle is 240 degrees. So this is now the sketch of 240 degrees in the plane. Example number 2. Find the angle in degree measure of 7/3 rotation clockwise and sketch the graph. So first thing we have to get now the 7/3 rotation clockwise. When we say clockwise, the angle of the rotation is negative. And take note that one full rotation clockwise is negative 360 degrees. So all we need to do is we are going to multiply now the negative 360 degrees to our fraction 7/3. So it becomes 7 times negative 360 degrees divided by 3. So as we are going to multiply now the 7 times negative 360 degrees, it becomes negative 2,520 degrees divided by 3. So as we are going to simplify now, it becomes negative 840 degrees. And take note that negative 840 degrees is more than one full rotation. So how are we going to sketch now the graph of negative 840 degrees? So first, we are going to make now one full rotation clockwise, and that is negative 360 degrees. And then we are going to extend again now our rotation into another one full rotation to make it two full rotation. So that is another negative 360 degrees. So as we are going to add now negative 360 degrees plus negative 360 degrees, that is equal to negative 720 degrees. So we are going to extend again our rotation to make it negative 840. So we are going to extend our rotation up to the negative 120 degrees from the 0 degree to make it negative 840 degrees. So we can say that this is now the sketch of the rotation, 7/3 rotation, specifically negative 840 degrees. Example number 3. Find the angle in degree measure of 23/6 rotation counterclockwise and sketch the graph. First is we are going to get 23/6 rotation counterclockwise. So, and take note that one full rotation counterclockwise is positive 360 degrees, and this positive 360 degrees must be multiplied to the fraction 23/6. So, it becomes 23 times 360 degrees divided by 6. As we are going to simplify, it becomes 8,280 degrees divided by 6, and that is equal to positive 1,380 degrees. Next is how we are going to sketch 1,380 degrees. First thing that we need to do is we are going to sketch one full rotation, and take note that in 1,380 degrees, it has three full rotations. the second rotation, and 3 full rotation. And take note that 3 full rotation is 1,880 degrees. And we are supposed to graph 1,380 degrees. So what we are going to do is we are going to extend the rotation from 0 degrees to 300 degrees to make it 1,380 degrees. So this is now the graph of the rotation, or the sketch of the rotation. Example number 4. Find the angle in degree measure of 21/8 rotation clockwise and sketch the graph. First thing is, since now the rotation is clockwise, we are going to multiply now the fraction 21/8 by negative 360 degrees. So as we are going to simplify now, it becomes negative 7,560 degrees divided by 3 is equal to negative 945 degrees. So as we are going to sketch now the graph of the angle, so and take note that in negative 945 degrees, it has 2 full rotation clockwise. So as we are going to add now negative 360 plus negative 360 degrees, that is equal to negative 720 degrees. So to make it negative 945 degrees, we are going to extend the graph from 0 degrees up to negative 225 degrees to make it negative 945 degrees. And this is now the graph of the rotation. Radian measure. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. One way of measuring angle is in radians. Definition of a radian. 1 radian is the measure of a central angle theta that intercepts an arc S, equal in length to the radius r of the circle. As shown in the figure at the right, this means that angle theta is equal to arc S divided by the radius, where theta is measured in radians. This illustration shows 1 radian. Why? It is because the length of the radius is equal to the length of the intercepted arc. That makes this angle theta 1 radian. 1 revolution around the circle of radius r corresponds to an angle 2 pi radians because around the circle, the length is 2 pi r. Substituting now the 2 pi r to our S, it makes 2 pi r divided by r. That is why we have now around the circle that is equal to 2 pi radians. Example number 1. Find the angle in radian measure of 1/3 rotation counterclockwise and sketch the graph. First thing that we need to do is we are going to get now the 1/3 rotation counterclockwise. And take note that in 1 full rotation counterclockwise, that is equivalent to 2 pi radian. So we are going to multiply now 2 pi radian to our fraction 1/3. So it makes 1 times 2 pi divided by 3 radian. It is equal to 2 pi over 3 radian. Then how are we going to graph 2 pi over 3 radian? So to make it easier to sketch, first is we are going to convert now radian to degrees to easily graph the angle in radian form. So 2 pi over 3. So all we need to do is we are going to or substitute now the pi by 180 degrees. So that is why we have 2 times 180 degrees divided by 3 is equal to 360 degrees divided by 3 is equal to 120 degrees. It means that 2 pi over 3 radian is equivalent to 120 degrees. So now we can easily now graph the 2 pi over 3 radian. So we are going to locate now 120 degrees, and this is now where the terminal side ended or stopped in 120 degrees. Now we can say that this is now the graph of 2 pi over 3 radian. Example number 2. Find the angle in a radian measure of 7/9 rotation clockwise and sketch the graph. So first, we are going to get now the fraction 7/9 rotation, and take note now that the rotation is clockwise. It means it has negative rotation. So all we need to do is, since now one full rotation clockwise is negative 2 pi radian, so we are going to multiply negative 2 pi radian to our fraction 7/9. So it becomes negative 14 pi over 9 radian. And how are we going to sketch now the graph of the rotation? So first, from the radian, we are going to convert it into degrees so that we can easily graph now the angle. So we have now negative 14 pi over 9, substitute now pi into 180 degrees, so it becomes negative 14 times 180 degrees divided by 9 is equal to negative 2520 degrees divided by 9, and simplifying now, it is negative 280 degrees. It means that the corresponding value of negative 14 pi over 9 radian in degrees is equivalent to negative 280 degrees. So by this degree measure, we can easily now locate or graph the radian negative 14 pi over 9. So first, we are going to locate now the negative 280 degrees. So approximately this is now the terminal side where stops, and this is negative 14 pi over 9. So this is now the graph of the 7/9 rotation clockwise in radian measure. Example number 3. Find the angle in radian measure of 7/6 rotation clockwise and sketch the graph. So the rotation is clockwise. It means that we are going to multiply the 7/6 by negative 2 pi radian. So it becomes 7 times negative 2 pi over 6 radian. So 7 times negative 2 pi, it is negative 14 pi over 6 radian. So as we are going to simplify negative 14 pi over 6 radian, it becomes negative 7 pi over 3 radian. Why? It is because 14 and 6 has a greatest common factor of 2. So 2. That is why 14 divided by 2 is 7 and 6 divided by 2 is 3. That is why we have negative 7 pi over 3 radian. Then we are going to sketch now the graph. So we are going to convert now negative 7 pi over 3 radian into degrees. So by substituting pi into 180 degrees, so it becomes negative 7 times 180 degrees divided by 3, it becomes negative 1260 degrees divided by 3. So as we're going to divide, it becomes negative 420 degrees. And take note that negative 420 degrees is more than one full rotation. So as we are going to sketch now the graph, one full rotation clockwise is negative 2 pi. Then we are going to extend up to negative 60 degrees to make it negative 360 degrees plus negative 60 degrees equivalent to negative 420 degrees. Or in radian, negative 2 pi, one full rotation plus the 60 degrees, it corresponds to negative pi over 3. So as we are going to sum up now this one, it becomes negative 7 pi over 3. So the graph of the rotation, 7/6 rotation clockwise it goes like this. Example number 4. Find the angle in degree measure of 7/3 rotation counterclockwise and sketch the graph. So 7/3 rotation counterclockwise. So when you say counterclockwise, that is positive 2 pi. So multiplying now 7/3 by 2 pi radian, we have 7 times 2 pi divided by 3 radian is equal to 14 pi over 3 radian. So converting now 14 pi over 3 radian into degrees so that we can easily graph now the rotation in. So it becomes 14 times 180 degrees divided by 3 is equal to 2520 degrees divided by 3, that is 840 degrees. And take note that in 840 degrees, there are two full rotation counterclockwise. So as we are going to graph, one full rotation, that is 360 degrees, and two full rotation is equal to 720 degrees. In radian, that is now 4 pi y, because since the one full rotation is 2 pi, so two full rotations, we are going to add now 2 pi plus 2 pi, that is equivalent to 4 pi. Since now 4 pi is just only 720 degrees and we are supposed to graph 840 degrees, so this corresponding graph must be extended up to 120 degrees. So in short, the 720 degrees will be added 120 degrees to make it 840 degrees. So in radian, 120 degrees corresponds to 2 pi over 3. This 2 pi over 3 will be added to 4 pi to make it 14 pi over 3. So the graph now of the rotation 7/3 counterclockwise goes like this. So this is now the sketch of the rotation.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.